Oh, I'm starting to record. Heck, I might even push this. I might even push the stream button on this one and stream us out to Twitch as we're twitching.
All right. So the question is, who do we wake up to tomorrow? Will it be Honest Dave, or will it be some guy with a beard, or will it be? Who knows? We'll leave that for the cartoon people to figure out. Okay, enough of that. Back to normal. All right, where's the?
Oh, also, Carl, I didn't.
There's that one too.
Oh, a little max headroom. That's good. I will
I wonder
answer.
how many people can actually remember him.
Hey. Oh, yeah. I don't know if you guys can see me because I got it on record mode now.
Okay, so you got the record going?
Yeah.
All right.
I guess I should put myself up in the corner a little bit here. Let me see if I can.
Harold, just hats off to you. I really appreciate it.
Not a problem, man. It's not a problem. I'm happy to help. I mean, for a long time, I've been taking good advantage of all this knowledge and stuff. And even though I'm sharing my knowledge back, I really haven't materially, so to speak, whether my time, effort, and energy directly to the club in these kind of activities. And I'm happy to do it.
So, Carl, we basically lost our subscription with the makerspace or something. How long is this going to last?
Oh no!
The fact that we can't record.
Oh yeah. Okay, so brief update on the recording, and then we can start it. So basically, the reason why we were able to record directly native to Google Meet was because Google, in their COVID kindness, provided the free recording for levels of like all levels of service, including the low nonprofit level that the DPRG has. So that ended in September, and as it turns out, if they would have turned on the free native stream recording, it would have cost like 80% of DPRG's revenue just to cover that. So needless to say, they're recommending OBS. And thankfully, Harold was all set up for that. So
yeah. Well, you guys don't get to see me very much. You guys don't get to see me very much, but that's okay. It's all right. We can handle that.
Okay.
I miss you, Harold. I miss you, Harold.
Oh, I wonder if I can do something a little different with that. What if I changed cameras and recorded with OBS on the thing and then have me join with a different camera? Let me try.
There's so many ways to wire it up.
There's also a.
Hey, who has something to lead us off with once we get going?
I can do my deal.
Doug D. All right, our designated first hitter. That's great. Okay, let me just. Harold, are you ready?
Yeah, I'm recording now.
Okay. All right. So, welcome everyone. Whoa. How many microphones? Okay, welcome everybody to the election edition of the Dallas Personal Robotics Group Robot Builders Night Avoid the Polling Places. And here we are tonight going around the table like we usually do to see what everybody is up to. In a moment, we'll start off with our normal lead person these days, Doug D. And momentarily, just a moment here. So at this point, in the spirit of today's election, I would like to designate that the polls are still in progress and the vote won't be done for months. So until then, we're going to talk robots. So Doug D., could you take us away?
Yes, I'll see if I can remember how to present. It looks like it might be working.
There you go.
Oops. Maybe it's working. Am I presenting?
Yeah.
Are you seeing, I wanted to switch to my home page, but when I do that, I don't see you guys. It might be. That shows my robot blog?
Yes.
Oh, good. So I've got it mostly working now, and I have my blog started up on my various projects, including Rogue, and some of my programming ideas and some of my robot ideas. You know, I've got my links working, including DPRG. And that's what I've been working on so far. And let me switch back over. If I can stop sharing. I think I stopped sharing. So this is my Roby base at this point. And this is my Arduino Nano that I've had on here for so far. But I'm going to be switching this out to a Arduino Uno. Haven't done it yet. But I need to be able to attach what I think is more sensor pins than what the Nano handle. And this actually isn't working right now. But my next step to work on this robot here is to switch out to the Uno, redo the battery compartment because I'm using the 18650 batteries in place of the original lead acid cover. And I wanted to put 2 sets of batteries in there. So one could be charging while the other is discharging. And so I'm going to be doing something to switch between those two and hopefully accomplish something good. So not too much, just a little bit. On to the next person.
Pretty cool.
Actual robots the next time.
We're all chasing on that at some point here, so that's good. Let's see. So who would like to jump in next? Who is ready?
I'll go
Good.
next.
Oh, Chris, and then John. That sounds good. Chris, what you got from the Northeast?
All right. Just, I guess, a couple notes on progress on my line follower. Remind me when the contest is again. Is an official date? I forgot what the official date was.
You know, it's December 12th, and if some elected official would got off of his elected podium and do something, then there might even be a post for December 12th. But someone ought to talk to the
Okay, good,
president.
good.
Yeah.
I wasn't sure if it was going to be late November. Or, anyways, no, okay, I'm good. I'm in good shape then. I think I'm fine. I'm good.
We've got a month
right.
and 2 weeks about, minus the holiday.
So, yeah, that's true. So what I've been doing is I guess I'm not sharing. So what am I doing? Hang on. Share percent. Entire screen, I guess. Okay. All right. So I'll just give a quick demo in a moment, but a couple things I've been doing that I just wanted to discuss, just in case anybody, has tried similar things or finds this useful. But one thing I've done, it's helping me a lot, is all the information that I gather up from a line sensor, I stick it into the structure, keep it all together. And I don't know any Java at all. I mean, it's similar to C++, but still, there are some nuances to it that's slowing me down a little bit. But it's okay. So most of the stuff I'm doing is not particularly elegant or Java-like, but hey, it works. So I found this a useful thing to do here: to stick all information I can extract from the sensor, into a data structure, and then as I have ideas about, hey, what other information can I extract that might come in handy, I put it in there, and then I decide, do I actually want to use it? Is it really useful information? Maybe I should have just actually hit the run button first to illustrate, because I've actually a lot of line sensors in there right now, and I don't really know, I'm not really using most of them right now. And so I'm mainly still trying to figure out sensors. Yeah, it looks like a lot of sensors going on, but again, I'm actually, most of the time, when I'm just following along, let's say a regular line with, I'm using mostly that, I don't know if you can see my mouse cursor, but that arc that's pointing forward, if you know what I mean. right? Where the tip of the arc is kind of in the front. I'm using that a lot together with the line that's the second from the bottom. Okay, so those are kind of my key sensors at the moment with my logic. I'm kind of looking at the front one, obviously, to see, you know, how far off center am I? But then the one in the rear is kind of telling me, you know, am I parallel? Together, I can kind of get a sense of how parallel am I to the line, right? Versus am I at some angle to the line? Right, so if I get this going here, just hit the on button. Now, one thing that you just notice here, and that's where what I was saying earlier about I'm extracting a lot of information from the line sensors and I'm sticking it into this data structure. And one of those things I'm doing is I'm extracting, you know, obviously I'm trying to figure out what's the color of the line. Is it more likely to be black? Is it more likely to be a white line, etc.? For that, I'm looking mainly at how much white is there, how much black is there. That usually is a good indication, not always. Then I'm extracting edges. You see those red dots, right? Those are edges I'm detecting. And if you can see the blue dot, that's where I think the center of the line is, right? So I'm visualizing that, and as I'm running along this course, I'm just trying to get a sense for, you know, all the weird situations. What am I picking up in those weird situations? What does it look like, right? How do I use all this information to decide if I'm about to encounter some, you know, some weird angle that I need to do something special about? Because that's really what's my main approach is basically the following. Most of the time, it's just going to follow along the line, you know, using just two sensors. Occasionally, it's going to encounter these weird angles and whatnot, right? And my hypothesis is that if I can detect that I'm about to encounter one of these special situations and I can react to it with a, let's say, a maneuver or a turn angle and a speed that's designed for that situation, right? And then go back to sort of default, you know, proportional control. That's currently where I'm at. And just to illustrate that, I'm going to hit the run button in a second. But again, so you can see here, I'm tracking the edges, I'm tracking the center. And, you know, it doesn't always work. You just see, if you see that line, the second one from the bottom, yeah, it's obviously, well, it's doing the best. My center of the line detection logic is picking this gap here as the center of the line, right? You see that? The blue dot, right? So those, I mean, there's obviously numerous situations where, especially when there's a transition from black to white, back into black, where, you know, intermittently my logic that finds the center of the line gets it wrong. And so, again, that's why I'm looking at multiple sensors just to get a sense of what's the better positioning. So I'm just looking at all of them visually just so I can get a sense of, you know, am I better off having some of these line sensors more towards the front or more towards the center, for example, right? Or am I better off making them wider? Does that buy me anything as I visually see things happening? Does it help me if I make these line sensors wider? And you see that very top one that I placed at the extreme edge of my workable region, right? I've made that one a little wider, you know, so I'm looking at that and see what happens. And, you know, I found that disadvantage of wider sensors is that you end up picking up neighboring lines that are not really what we're interested in. So that can cause confusion, right? So there's a trade-off there. So I'm just visually trying to really take it all in and you know, and find out, you know, what indicators can I use to determine that I've reached sort of special landmarks, so to speak, that need special treatment, like that acute angle. And I'm just gonna go to that one. Why is it not going? Controller off, controller on. Okay, I'm in frozen. Okay, go. And this is a slow laptop, so it's going much slower than real time right now. about a third of real time. Okay, so one thing I've done here, and that's what I wanted to show in the codes, things that I found useful. See how it stopped? I'm not actually at a breakpoint. Basically, I've reached the point where my logic has detected that I'm at this acute angle, and I've just basically toggled that freeze flag. But my strategy is sort of, so here, this is where my code just reached. I'm detecting the intersection by looking at, in this case, I've decided to look at how many edges am I seeing, right? Sorry, not intersection. Acute angle, this guy right here. How many edges am I seeing is mostly what I'm looking at. In this case, I'm looking at 4 different line sensors and how many edges they're seeing. But then I'm also looking at how many simulation steps have elapsed since I've started, because looking at how many edges each line sensor is picking up is not a guaranteed indicator that we've reached a certain landmark, because there are just too many situations where the pattern is going to be identical. So I'm looking at time elapsed within some range to tell me, okay, well, if we're early on here, right, in the run, it's got to be an acute angle. That's it. That's the only thing that can cause this pattern, right? Later on, it did something else. And then, again, I've put the freeze on here just for me to visually be able to examine what my senses are actually seeing, right? So that's what caused it to stop. But at times, I've also basically just put a breakpoint here. And sometimes these if statements are empty, so I found it necessary to just put a dummy statement in there, just so I can set a breakpoint. That's why there's this sort of breakpoint equals 1 statement there. That's really just a dummy statement, copy and paste, for situations where I've got nothing else yet in my if or in my else, branch of the logic. So sometimes I find it useful to set a breakpoint and run it in debug mode, and then sort of examine, the full state of my line sensors, not just sort of the edges visually. But just earlier today, I realized, hey, this, similar to a breakpoint, right? Just putting it in the freeze mode is a useful thing, because now I can go in there, right, and I can zoom in, and I can kind of look at my sensors and say, all right, what, how close to the, are there any corner cases I need to be worried about? What are my sensors seeing? What if I'm coming in at a little slightly different angle, right? So I can move this around a little bit and see what's happening with what my sensors are picking up, and just kind of confirm that my landmark detection logic is, semi-robust. And then, let it continue. So if I let it continue here now, I've messed around with it manually, so it didn't do a nice turn here. Usually it does a little bit better on this angle. So again, right now it's just following the line, like I said, using 2 sensors only until it, the only other landmark that I'm explicitly detecting at this point in time is an intersection. Now, in an earlier version, it was just by sheer luck going straight through, but I found that I had to kind of do some special logic just to make sure I don't get confused and make a right turn or left turn. So basically what I'm doing here, okay, so again, it put the freeze on, it detected an intersection, by looking at mostly the number of edges I'm seeing, and then I'm basically saying, okay, let's just go straight through. Basically I'm saying in the intersection, well, let's just say the center of the line is, and you can see right here, and that's why I'm doing this, you can see the blue dot here to the left. That's where my, initial center of the line detection logic is picking up the center of the black line. So it almost looks like a left turn here, according to that logic, because that logic isn't yet looking at the edges. But then if you take a step back and look at all the edges, I'm seeing 6 edges on this sensor. I'm seeing another 6 edges on this sensor. Well, I'm right, on top of the intersection. There's really no other way to get this pattern. And so then I just say, you know what, if I'm on the intersection, I'm just going to say the center of the line has to be between those 2 middle edges there, right? Again, the visualization isn't reflecting that. But in the code, you can see here I'm saying, well, if we're at an intersection, I'm going to override what I've calculated as the line center and give it a new line center so that I just go straight through. And that's basically going to happen here. And then, at that point, it's pretty much how far I've gotten things. So once it keeps going here, and I'm just running it in slower speed. And I've also reduced the speed because I know this is a tricky spot yet for me. Not so much traversing this angle that's on top of black, but the transition from this into this area of E2 where we have the gap. Again, an early version did it just by sheer luck, but that's kind of where I'm at right now. I need to detect this landmark here. I mean, I know we just crossed the first intersection, so I know I'm here now, but now I need to figure out how to straighten myself out a little bit better, by the time I get here, and then basically say, okay, ignore the fact that we don't see a line, just go straight, right? But that's kind of what I'm working on now, and then proceed from here basically. But if I just let it go after helping it along a little bit, again, it's doing the rest of this. I need to increase the speed back to maximum. So these S curves, it's also still messing up quite a bit. All right, we're back in an intersection. So I think you get the gist of it, in terms of my approach. Follow the line if we have it clearly in sight, using simple proportional logic, and detect landmarks that require special, attention for maneuvering, and then implement a maneuver for those landmarks. And what that looks like is, the beginnings of a simple state machine, and I don't know how to make that a little bit more elegant in Java, but basically most of the time I'm in this state 0, and then just executing my simple proportional logic there that's, steering left and right depending on how far off the center I am. But if I've accounted a certain landmark, like in this case, the acute angle, right? I'm going to go into state 1, another state in my state machine here. And then while we're in this state, I execute a different logic, right? Because I can't just follow the line at full speed with the same, parameters. That's just not going to work. So I have special logic in place for making that tight turn, okay? Which is actually quite primitive right now because I'm just saying, okay, slam on the brakes, turn a hard right, the maximum turn, speed, and do that for, a little bit of time, empirically determined. Just do it for 24 simulation steps. Doesn't need to be super accurate, right? That's all. That's all I need to do, right? Slow down hard, turn hard, and then when we're done, well, go back to sort of state 0, which is run the regular proportional logic that just kind of slows down when we have a turn to make and then speeds up again in straight line and so on. Sort of the standard logic, again, is quite simple. The theoretical center of the line is what that, right? Depending on how long, if I have a line of 41 in length, so center equals like 20, then I calculate the error. Another error that kind of from the other lines that tells me how much we're parallel to the line or not. Combine the two and calculate a turn rate from that. And then the speed is based on my max speed, but I subtract some amount from it, which basically amounts to, well, if we're turning hard, we're also slowing down, right? That's kind of the theory here by, not a very specific amount. So some of these are tunable parameters here with Ron's fabulous sort of parameter tuning feature, which is really handy here. But, I found pretty much my values, so I am not usually tuning those anymore. But that's, again, very simple logic. provided that we have a good line to follow, and it works for most of the turns, including the, most of the 90-degree turns that we encounter. It works fairly well. Let me sort of manually move it in a better position here. It slowed itself down again, so let me speed it up. So even for those 90-degree turns, it just happens to work. Those offsets are not an issue. And really, it's about, all right, we encountered an intersection. All right, keep going.
It's looking pretty good, really.
Yeah, so again, those weird S1s I'm gonna have to work on. These stains are not an issue, and that gate I haven't worked on. So it's not doing all that much better than maybe a week ago in terms of final result, but I have a lot more logic in place to actually deal with different situations, versus previously it was just more by accident doing a good job. Now it's more sort of deliberately dealing with the tougher situations, so that again, not just counting on luck here. So the one thing I had to stop myself from going, the rabbit hole I had to stop myself going down into is, or the thing that I'm still a little frustrated about, is the fact that I realized there is actually a theoretical best case that you can achieve, right? Because you have all the information available that there is, right? With those line sensors and being in simulation. But I'm getting frustrated that I'm probably not able to run as fast as what's theoretically possible. Right? That's what I'm trying to say, right? And I think given that it is simulation and that you have all perfect information at your fingertips, right? I'm thinking, hey, I got to be able to put the perfect algorithm together to run at maximum speed, whatever a given turn allows you to do, physically. I'd like to be able to get there, but it's not going to happen. So I just had to make peace with that. But that's I think that's just the reality. But it'd be interesting to know if somebody, maybe Ron knows what the theoretical best case is, right? How fast can you theoretically run that course, right? Given the limitations imposed by the simulator, which is mainly, a finite acceleration and deceleration, which is really bugging me, because I find it actually a little unrealistic in some regards, because any real robot I've had so far, if I slam on the brakes, that thing stops. Acceleration may have, a little bit of a delay to it, but slamming on the brakes with a real robot, I find that it responds pretty fast to it. And even turning on real robots, and again, I use mostly smaller ones, so maybe that's why, but they tend to respond fairly well. The simulator is imposing sort of finite acceleration and deceleration and turning that, I'm finding a bit unnatural. But that, it's okay, right? That's what that simulated robot is capable of. Nonetheless, there's a best case, right, that someone in theory can achieve, and I'd like to know what that is.
That sounds like my wife's old Plymouth Horizon, because you'd hit the brakes and, maybe it would stop eventually.
But Chris is also, we could quote Donald Knuth, because it's sort of like, what's that? Premature optimization is the root of all evil and all that. You haven't got through the whole course yet, and you're still trying to
No, again, I had to stop myself from going down this rabbit hole and getting too perfect. So I think I managed to stay away from doing that. So but it's still bugging me right in the back of my mind, knowing that there is a best case. I'd like to know what it is. I ought to be able to put that logic together, but realistically, I'm not.
So maybe you need a better tool. And I've been working on
Perfect. This is a constraint. This is an engineering constraint.
Well,
And we will design our country around this engineering constraint.
one thing that's bothered me is the speed of the simulator has been fairly poor in my estimation. And I wrote the foreword to the latest document where I was talking about the Apple II, and there was an obsession to have to try to optimize everything and reduce arithmetic precision and live with no memory, all of that. Anyway, so that did inspire me. I wanted to speed up the step rate on the simulation, and my goal was to double it. But I've surpassed that, and I think Chris will like this. My goal is to be able to run the simulator very fast, and so that's what I've spent the last couple days working on. And,
Yeah, see, I don't find the simulator to be slowing me down. It's my brain.
Okay. Well, let's look at. I've got a tool, and also I guess Kareem's working on get moving into his house. So I did work on. I'll present. I guess I did work on his simplified 2-sensor robot. Let's see. I'll present.
Wait a minute. Now you're doing someone else's robot, Ron.
No. Just setting it up for him, and then they can run with it. Hang on. Let's see if
I don't know. Setting up and doing it for them. I think it's that's an equal sign there. I'm thinking. I'm just saying.
Well, I wanted to. I guess one of their problems was translating. Am I presenting? Is my screen up over here?
Yes.
Good.
Okay, great. Anyway, so I did get their robot figured out. It really was the basic problem of kind of backwards of going from he wanted left and right wheel velocities. And so really what I did is and he said that students are, they're not at that level. Well, some are high school. So I guess this is high school math plus slightly. But anyway, I did work out for them a controller where you specify a left and a right wheel velocity. So anyway, it's the backwards version of probably what you do to come up with left and right wheel velocities given a speed and a rotation rate. So I won't waste much time on that. But I wrote this little translator that takes in wheel velocities and generates what LFS wants. And I'll demonstrate their controller. So I just kind of set it up with a real simplistic, mindless controller thing, and then let them improve it. But I'll demo that. Let's see, and it's pretty fast. And I'll show you some early faster frame rates. Notice 600 frames a second. So that means this simulation will run a bit quicker than it would have in the past. So I'll say go. So even though the velocity we just watched, about a minute per lap, but obviously we're running much faster than real time. And the cool thing about this is we can tune it. It just finished. Oh, wait a minute. It's doing a lap race. Wait a sec. Okay, go. And I can play with, whoops, too fast, But anyway, it's easier to turn the knobs on something that runs faster. But let me show you something really cool. Okay, here is Will's Trike demo. And here it's running 100 frames a second, but now we have a new mode. Okay, so let's just run it in that mode first, I guess. Okay, so his robot's running twice real time. That's not bad. And of course, we can slow it down and whatnot. But okay, now for the fun.
Wait a minute. How is it able to make that turn? See, that's where.
Oh, you have to look at his controller. He's got a smart, whatever. He's looking at cases and then doing open loop turns and things like that.
No, I mean, it's more like, how is he able to achieve a tight turn like that? I remember last week I asked, was there any benefit to doing a trike style? And I realized it's, really the same as a differential wheel. Because it almost looks like he's able to make a tighter turn than I'm able to make.
Well,
if you're going slower.
Okay. Yeah, of course you can always let's think. Well, if you slow your velocity enough, and you can turn on a dime. If you stop your forward motion and just give it a rotational rate, you'll stay in place. But anyway, let me show you this. Okay, now I have the time warp. I think there's actually a soundtrack. Now look at the frame rate. Can you see that in the upper corner?
Yeah.
Okay, ready? Oh, it's bogging on the screen on the too bad on the screencast. This robot runs that instantaneously without being on screencast. So interesting. Darn, I'll have to publish a YouTube video. Anyway, but the cool thing about this is that without the screencast, you can run a fairly good chunk of the course in a fraction of a second. And I have a loop feature, and what it does is we're not really able to appreciate it here, but the loop feature allows you to restart. And it's interesting, with the screen capture, it is not repeating the same states. So, I've got a problem with screen capture. But anyway, but without screen capture, it's pretty predictable. And then you can sit there and tweak parameters while the simulator runs the robot through its paces. Now, it's not for every case, but it's great when you want to be able to quickly progress to a place where the robot's messing up or whatever. So anyway, but I can't really. I'll have to make a YouTube video for this to illustrate it. So, too bad. Screencast won't capture the fun. Anyway, so anyway, that's what I've been doing, and I think it's a cool feature. But the thing about it is, with that, I will have the ability to throttle the robot down, normal speed, single step, all that. So that's the feature I'm working on, and it's keeping me from working on my controller. So I really need to quit this. But anyway, so the speed up is anyway. I was able to get 100 times faster speed. So that's because of the Apple II days, and the cruddy little computers. So anyway, but.
How are you able to do that? Are you basically not rendering the screen? I mean, that's really the only.
And that took me. I'm a slow chip when it comes to that. I'm obsessed with using the GPU for everything, and I realized, Carl's freaking me out. Anyway, I realized that for this task, the GPU can only kick out about whatever, in my case, I guess 700 or 800 frames a second. And as soon as I start accessing frame buffers and doing stuff, I bog to the hilt. So yeah, I scrapped the GPU in favor of the CPU, remembering that it's compared to what I had with a 6502 with its 3000 transistors and a 1 megahertz clock speed. Anyway, I kind of just got into that mindset and whatever, figured out how fast I could get the thing to run. So anyway, I think it's pretty cool. And I think I did that with David Anderson's spiral drive thing, his pirouette. It occurred to me I wanted to see what his robot did in a 60th of a second, what it did over a period of, 10 or 100 seconds. And I didn't want to wait for it. So I think this feature will be really cool, but it's fairly transparent. There's just a couple of commands, the time warp command and a loop command that'll repeat the run. And Will had a good idea, which is run at warp speed until you hit a marker and then have it slow down or stop. So I think that would be pretty good. And the cool thing about that is in this last release, I was touting kind of like what you're doing there, Chris, having a structure that saves the state of the robot and everything, the contest. Anyway, with the time warp, you're not so reliant on needing to save state, because you could run the robot up to, let's say, the trouble area with the gap. It'll run to that point, at warp speed, executing faithfully the simulation. And of course, time is clocking up, a minute or 2 minutes, and then bang, freeze right there, and then allow you to single step or run slow. So I think that's cool. In fact, that I spent a lot of time with that state saving and all that, and just knocking myself out. But in reality, that stuff may not even be needed, but I won't ditch it. So anyway, that's the story. Any questions? Carl is still freaking me out. I got used to Abraham Lincoln. Now he's thrown in.
Oh, we can go back to that, or we could, no problem.
But I want to get to work on my controller for sure. But I am sort of.
Really should.
Ron, I had one question, which kind of came out of Chris talking about what he was doing. Is there anything to stop someone from simply dragging the robot through the entire course and then just memorizing the positions and just driving that course?
Well, I think that's kind of considered cheating. But yeah, that's for sure. One of the goals was to add, in fact, what I did with Kareem's robot is I gave it the ability to run straight because I guess the idea was in that case running a left and right motor with a low cost motor situation. I assumed that I added one of the laps after the first lap, which was a perfect lap where the motors would run the same speed. I then said, okay, let's make the left motor run 10% faster than the right. And then that made the robot tend to curve. And the controller still with the two spots that you saw still did a pretty good job. And I'm now losing my train of thought because I am cooked. Talk to me, and Carl's freaking me out.
Well, yeah, Carl, maybe that doesn't help much. It's really it kind of. There was that email message about AI and mistaking I think it was a football for someone's head or something like that.
Yeah.
And it kind of, there's the whole philosophical argument that I almost started typing up and I just kind of gave up on, that this kind of gets back to, and it goes back to something David Anderson talked about with his robots, which is that it's actually really hard to make a robot that it is a general purpose robot that you can just let go either outdoors or indoors. Like you might have an indoors robot and an outdoors robot, and it would be able to handle anything. Like it could handle a stump or a hole or whatever it came across. And to me, the same thing with AI is that AI that's been trained to understand the green background and a ball and a bunch of people running around wouldn't know what to do with a white cat that ran across the field, because it's never seen that before. And this just kind of gets back to what is AI? And AI is not simply, I would argue that training a camera with a bunch of images and having it recognize images, it doesn't understand what it's looking at. It doesn't know what a ball or a head or anything is.
Yeah.
It's just doing pattern recognition.
Yeah, I prefer to do that problem analytically and not screw around with teaching it, what a hamster or a bald person looks like or whatever. I found, anyway, go ahead.
But like my background's in knowledge representation, and that's like the other side of what, because right now we're using massive computation to basically look for patterns in literature or images or whatever, and just do statistical analysis, and that's considered AI. And the old school way would be like the psych ontology, which is, I don't know if you guys are familiar with, that's actually a Texas project. The PsyCore in Austin. Anyone heard of that? It's I actually in 1979 I went to Stanford Research Institute as a prospective student and saw it demoed, and it turned into, I saw it demoed in 79, and then I actually had dinner with the guy in 2000 or 2002, Doug Lennett, who actually built it. And it's basically the largest computer-based ontology in the world. With an inferencing system, it could read web pages. It was a huge system, and it had a pyramid structure ontology with thing at the top, and then an abstract top structure, a productive middle structure, and then the lower structure was basically all the detail. And this could infer basic ideas about things, like it would know that a ship's captain faces forward when he's in charge of the ship, things like that. Of course, that system was the biggest in the world, and you don't hear much about it. It's a productive system, but it's not being used because it failed for different reasons. Then you've got self-driving cars, which fail for the opposite reason. And so what I was going to write into the mailing list was sort of that we kind of need hybrid systems, ones that have some model that knows that background of green on a football field is the background. There's a plane. It's that, some model of the universe kind of thing that it can understand. And that way it knows that a ball doesn't sit on someone's head. And then we can infer the difference based on some logic, not just training it on images. That's the kind of thing that Rodney Brooks talks about, I think, as well, is that, this idea of the either or, either all the way to the computer-based ontologies or all the way to statistical analysis of images. Neither one of those works very well. We've seen flaws in both. Like a car driving along the highway that for the very first time sees somebody in let's say, a mirror-colored raincoat. That person's going to get killed. It's like if you do the wrong thing in front of a self-driving car and the car's not trained for that thing, like let's say a reflective raincoat, you're dead.
Well, that's where redundant sensors, of course, would make sense, right?
Well,
You
in
have
theory.
radar, you have maybe someday it'll tune into their cell phone or whatever, like a transponder, multiple overlapping sensors. Anyway,
But if your system can't model in some way based on what you've got sensors, you're reading your environment, but if you also don't have any model of what you're doing, you're just relying on imagery, and you don't know what you're doing.
Right.
You can't make any judgment about what you should do if you get out of the situation you haven't been trained for, like this
right.
all. And so kind of the same thing with the, this is what I was trying to get back to with Chris, was that Chris was basically saying, I get to this point in the course, and there's a sharp edge, and then there's this and there's that. But it's not trying, and that's why my question came up about, couldn't you train the robot to just follow the path, which is the other side of that. One is trying to create a model that can handle anything. If you shuffled all the tiles of the course, the robot could still find its way through. Like you put
Okay, I misunderstood what you said earlier. I thought you were just talking about recording the path, or were you talking about that for training purposes? Record the path.
I'm kind of pointing the opposite direction of where I was going, which was that if you let's say you had a program that could shuffle all the tiles, and then the person coming at the course wouldn't know what the course was to begin with.
Right.
Just basically, they would not know where that acute angle was going to happen. It could happen at the end of the course or the beginning of the course or halfway through, but they wouldn't know that it's, let's say, 5 tiles in.
And that's why I said I'm kind of frustrated with myself that I can't come up with the ideal solution, right? Because you have all this information, the course is fixed, the sensors are perfect, there's no noise anywhere. So yeah, you can, no matter how you approach it, right? You could do this optimally, no matter how you choose to do it. And right now, my logic is kind of counting on the fact that when I reach the first intersection, shortly after that, there's going to be a certain maneuver I need to do. And then maybe the next intersection I know is a precursor to some other maneuver. So if you shuffle it around, yeah, I would still detect the intersection reliably, but I am kind of baking into my logic right now knowledge of the course, explicit knowledge of the course.
Yeah, me too.
Because that's the problem that's given, right? That's how the problem is defined. I don't want to make it harder than necessary,
Right.
for myself.
My point about, like, if you know what the course is, then you could just draw a line through the course and just follow that line. And that was the extreme example. The less than extreme example is what you're doing, and the other would be basically having the most perfect robot that could handle any course that it came upon, that had all those elements, the dirty elements, all the pieces, but in any order. And the perfect robot could handle that course at the same speed, no matter where those pieces came or those elements of the course came up.
Yeah, I'm finding it hard to do
after we solve this.
Sorry, go ahead.
I was going to say, and that's what we'll all aim for after a few of us solve this course.
There you go.
Yeah, it's hard enough as it is. I mean, again, especially if you want to run it fast, right? I think what makes it in the end hard, I find, is, as I said, the fact that you can't go at max speed and then instantly turn, right? It just doesn't work that way. And so that makes it a little bit harder, and kind of hard enough for me right now.
But that sounds like, to Ron's credit, that's actually like a feature of the game, not a bug. Like the fact that you can, with a real robot, you could never go around that corner that fast. That makes it more realistic.
Chris feels like he could. No, he's got
My 3 pi could.
Yeah, see, there you go. I knew turn rate wise, when I thought about it, I think I looked at my stepper robot, and I think it over 1,000 degrees a second. I noticed I limited it to 720 and whatever, two rotations per second. And then the acceleration rates, I thought they were pretty good, but I guess your 3-pod can accelerate faster than that.
Well, Ron, actually, what you could do is you could add a feature called drift, and you could actually drift the whole course like a race, like a.
Well, did you see my warp? I did a real-time warp for the course where it stretches. That should be somewhere in an email in a DPRG list. Yeah, I made it. I might be able to bring that up. Anyway, while someone else is talking, I'll see if I can find the course warper. But yeah, so what I did is to make it a little more challenging, although it makes you sick to look at it.
We should have that.
I like the idea of shuffling the tiles. I think that is something for future, contests to consider. Same basic features. Let's not make it impossible, right? But you don't know how it's going to be arranged. I think that's fair.
Yeah, well, I did create a tool that will assemble, or it's a semi-automatic tool that has a dictionary of all the tiles and the orientations. So all it would take is some logic to make a course that makes sense. It doesn't. I don't think. Well, I think one I actually had where there was a path through the course that was. I forget how to say this. Well, put it this way, I think what I ended up with requires a human to make a sensible course. But in other words, you have the different types of whatever, curve, straight, the selection of a line width modifier, a shift, and whatever. So it classifies all the tile types. But what I think I might have removed from that was the entry exit information, which wouldn't be hard to get back in there, where you could then have an automatic course generator. But you do need that entry exit information to help you, do a path or whatever that makes sense.
I agree. I think that originally the idea was that this course would change year to year. It would change, but when nobody was able to resolve it.
Because so many of us would solve it each year, right?
Well, the thought was that it would get solved each year.
Yeah.
And that's why the gate was put in. The gate, at first the thought was, well, the only thing that would change every year would be the gate. You'd have the gate, instead of turning on the second side going left, it might be the first side on the right, but the rest of the course would be the same. But you remember, I don't know if you recall, but when we first did this, we had a paper course, and it was donated to us by Bex, and we didn't have the vinyl courses, the ability to get the vinyl courses as easily as we do now, So it was a different situation. This thing's from 2011. That's 9 years ago. That's a long time ago. So anyway. But I agree, Chris. What we would like to do is have it to be where you could just shuffle it up. Or the first step would be to verify a robot by simply starting it in another location. You just pick another square and say, okay, now you got to start here. You can go through the course. You're golden.
Yeah, you're right. You mentioned that that was brought up previously. I think you're right. That makes it already much harder.
Yeah, but I'm not suggesting that for this first time. What I'm saying is that if you wanted to demonstrate that you were truly course tile placement independent, I don't know if that's correct what I said, you could simply say, okay, now that I've run the course, I want you to start it somewhere else, and I want to show you that it would work anyway. So like right now, you're in your case, it probably would fall. Well, it'd be interesting to know if it would fail on that acute angle, because you're really saying that there's several situations that would trigger an acute angle logic. So, and in my mind, I'm trying to think, I'm not sure exactly where they are. And so I'm not sure I necessarily agree with that.
Well, again, to the way that my sensors look at it, it looks the same, right? So it's a matter of looking at the right information.
But
No.
give me another place besides.
If you're coming up to an intersection and you're not hitting it straight on, but you're hitting it from an angle, that one coming in from the side can look like it's the acute angle coming in.
Okay. Yeah, well, another thought, I'll throw it out there, is that you can retain a history. And what you do is, you know, if the thing goes away quickly. See, the thing with a rectangle, with a intersection, is you never leave the line. You may interpret the line differently, but you never are in a situation where you have no line. If you're going into the acute angle and you overshoot it, you immediately go into a situation, there's nothing there.
Exactly.
Okay, so what do I do? You know, so there's only three things you can do: turn right, turn left, or go straight. Now, the way most people handle the 90-degree turns is they turn in the direction that they last saw the line. So like when they cross over the 90-degree curve, they got a big long strip in one side and nothing on the other side. So the thing's gonna go and turn where the big strip is. Okay.
Unless you have a curve sensor, then you never lose the line.
Well, that's true, but I'm just saying traditionally, Ron. So
Traditionally?
well, I mean, you know, we had an advanced course before we had this one, and the advanced course, you know, had 90-degree turns. I mean, a lot of clubs have 90-degree turns. That's not unusual. And if you look at this one at the acute angle, it does turn into the direction of the line, but it's when you last saw the line back in maybe 2 or 3 steps ago. So anyway, I still think you. The other thing to note, just so people know this, all of the tiles are 12 by 12, except for the acute angle. The acute angle is, I want to say it's 24 by 24 or something like that.
So I just wanted to ask Chris if he thinks he can follow this course. Yeah, you get extra points. So the idea was that one warp would be chosen statically, but if you're clever, then you can follow it while it's animated. Without throwing up. That's right. Okay.
Ron, that's pretty awesome.
Well, my opinion is that if you're going to have the perfect or a good robot that can really follow a line, make it go backwards on the course.
You know, start easy like that. Yes.
Well, I'm not sure that the gate would be interpretable in the same way.
Well,
The gate would going backwards. You'd have to have a forward logic and a backwards logic.
But I
The
do
rest of it fit.
because if you can actually go through the course in either direction, you could do an average of both, and that would be that might be a different contest. Like going through front ways is one contest, but being able to go both ways, you then do the average of the two or something like that, or maybe two.
Yeah, I think you get the same thing though by just randomly dropping the robot on a course. And like I say, if it's truly independent, it won't matter where it starts.
Sure, but this would be a test of independence.
Yeah, but I have to say you have to be going in the same direction because, like I say, the gate is really not symmetrical from direction. Okay, but I mean, I don't know. I haven't really thought about it. I haven't looked at it. It might not be that big a deal to write forward and backwards code for it.
Well, can you just flip the graphic, the gate?
Rotate, I think you might be able to rotate it, but I'm not sure. I don't know where the entry exit points are. I said that all of them were 12 by 12,
But
I
that's,
think it was 12 by 12, but it's weird.
Yeah.
It's really 24 by 24 or something like that.
and it kind of does violate the general course ideas as far as how often you have changes in features. The gate's kind of really its own animal. Not that I care or that matters, but it's slightly inconsistent with the rest of the kind of consistent course, really.
Right,
I guess.
most of them have the entry or exit points more or less in the middle of the edge of the cube, but the gauge.
Did you say cube, Carl?
Cube.
Carl's thinking in higher dimensions. I just fought him on that.
It's an N level challenge course tonight. N level.
He plays three-dimensional chess too, right?
Yeah, I mean, maybe if we're doing this simulation thing, if we get enough people, I'll spend a little more time and make a true 3D version. And I don't mean 3D in the sense of a 3D robot, but maybe we should have a 3D course, or maybe it should be on the surface of the moon or something. I don't. Since maybe we're going to get to go there one of these days.
Mars.
Well, getting back to Murray's conversation about AI and such, I was thinking about that sort of stuff myself when I was working on my blog. And I think my opinion is that an autonomous robot these days is really just a collection of behaviors. It's a little bit like my dog. It can learn behaviors, and it kind of selects between which behavior it wants to do right now. And that's based on the robot, on what sensor information it's getting, what commands it's getting.
That sounds an awful lot like me.
Yeah,
Are you making fun of me?
Well, but Doug, actually, you're quite correct that the reaction, because like the early robot projects at MIT and other places were trying to create these very idealized environments with models of blocks and things like that. And it was Rodney Brooks at MIT and his team who came up with this idea of behavior-based robots, which was literally what you're talking about, where they would charge up a robot with 5 or 6 or 10 different behaviors and no model at all. Just very simple behaviors based on sensors, put them all in a robot and let the robot go, and that's where you saw the overall robot behavior, was the collection of all those. And that whole idea of behavior-based robots is literally like an insect. It doesn't have any model of the universe. An ant doesn't know anything, really. It just reacts to its environment. And that's kind of what Rodney was on about. He was basically criticizing the idea of roboticists and AI people who were like Doug Lennett, who were trying to create these massively complicated models of the universe that were trying to model everything that could be. And that failed, but then behavior-based robots kind of had their own limitations as well. And so, like I said, I'm kind of arguing that there needs to be some kind of a hybrid between like a behavior-based robot that also has some kind of a model, very maybe, not an entirely accurate model, but some model, like a green field, that football is played on a green field. That's part of a model. And then you can say, well, if the ball is on the ground, in soccer, football, it's supposed to be on the ground unless it's being kicked. See, there you're starting to talk about an actual model rather than just images that you're trying to figure out what the images look like statistically after we showed the robot, thousands and thousands of images. But I think you're right. That's certainly what I'm doing. I'm basically taking a robot that has a bunch of sensors and just letting it go and seeing what happens without any preconceived notion of what it should do. It has I think David Anderson was talking the same thing, that, he puts his robot on the ground and he was saying that how you tune your PID controller is how jerky the robot is. Like you can make a smooth moving robot that's graceful, or you can make one that turns very sharp and looks kind of like a robot. And so that's kind of getting back to that whole idea of what behavior is.
The model-based robot, when I'm looking at this line following, my initial plan or expected behavior is, since it's tile and it's lines, that I would like to figure out where are the tile boundaries, and whether that tile is normal or inverse tile. Then if I can figure out these line patterns, maybe there's some noise, some stains, or some cross sections. But basically, it's going to be I hope it's a continuous line that that the robot can figure out. So I mean, when I work on this automation, it's similar to what would a manual process do? Like when I look at it, how would I say this is the line I'm going to follow? So that's where I wanted to start with. But I mean, with our simulator, I don't think that's a viable option because we have these dotted sensors, right? So when I see Chris' explanation, I'm thinking, well, how do you figure out whether it's a boundary of a block or a tile? Or how do you know whether it's an inverse tile or normal tile? I guess when I'm really able to work on my own robot, I would like to use an image, a video image where I can detect these.
Let me give you a real short idea. This is not going to be the whole solution, but if you scan across a white line on a black box, right? Okay, you follow me? We got a black tile with a white line.
Like that.
All right. Now, if you're reading across the line, all right, what is the first transition? It's a black to a white. Okay.
Not necessarily.
No, wait a minute.
If you're just entering the tile.
I'm trying to keep it simple, Ron.
Oh, okay. Oh, trying to keep it simple. Okay.
But what I'm trying to say is, and that's why I told him it wasn't going to be the full solution, because I think what you have to do now in the case where Chris has got like 5 lines, I don't know Chris, it looked like he had 5 lines. You know, he can also sense, well, the first transition is a black to white, and then the one that's closest to his wheels is a white to black transition. So he knows he's going over a boundary. All right.
Really detecting where the boundary of the tile is.
Right. He knows he's going over the boundary. But the trick is, in the simple case, when you only have 2 transitions, okay, now like when he's talking about situations where you had 6 transitions in the line and all that. So there's a few things that you should know. Well, one, if you have a line, it's going to have 1 transition that's going to be the opposite, and it's going to be followed by another transition that's going to be opposite of the first transition. So like if you get 2 black whites in a row, one of them is false. You don't have to worry about that one. So, but if it goes black, white, and then somewhere else it goes white, black, then you know you're on a black tile with a white line. If it goes from white to black and black to white, you know you're on a white tile with a black line. All right. Now, like I said, there is this case of, well, what about when you're transitioning from one to the other? Okay, there's 2 ways you can handle that. One, which you simply have 1 sensor, 1 line, and you drive over it. Okay? And when you drive over it, the only place that's going to be super critical is when you're exactly at that line point. But if you get something that's confusing and throw it out, your next time through the loop is going to put you over that spot. Do you follow me?
I see. So
Okay.
make sure not to get lost at the boundary, and then you're in the good
That's just
location.
1 line, okay? That's just 1 line, and that's not, again, necessarily the best way to do it. The way Chris did it, or I'm assuming the way Chris did it, he has 5 lines. All right, so he's picking out the edges, the 2, were they red spots that he had on his thing, and then he has a blue spot that's where he thinks is the center of it. All right. So, but if he was looking at the transition, when he goes over, he's going to start seeing that they change. All right, but the line shouldn't just away. You should still see they should still be in a row until he starts getting into a curve or something. So anyway, I'm just saying that, there's more information than, I mean, the transition information and the differential information can provide you stuff. And you want to look at that. You just don't want to try to say this is black and this is white. You follow me?
Well, Doug, what it sounds like you've just described, and I can't say I'm participating in this exercise, but it sounds like what you've described is that for every one of the sensors that you have on the robot, you would have one finite state machine. And then you'd have one finite state machine for the whole robot that would read all the states of those. Let's say there's 5 finite state machines, one for each sensor. Then you'd have one finite state machine that would read the 5 and then make judgments based on what the robot should do based on the state of each of those.
Okay.
And then,
I think you could technically call it a state machine, but it's much simpler than that. I mean,
well,
to me, a state machine doesn't really come into being until you have 4 or 5 states. I mean, if it's just got 2 states, or 3 states,
you're talking about transitions and things like that, and that's
you're reading your sensor.
Mm-hmm.
Depending on what you want to do, if you always read it from the left to right, and that's what I suggest, what I was demonstrating. If you're coming left to right, and you're on a black square with a right line, you're going to have black, 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 black. And then assuming you're only using binary numbers, you're suddenly going to have a white line. So it's going to go black, white. So that first transition will be a black, white. Mm-hmm. If you keep going across, it'll go white, 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 and then somewhere you're going to hit black, so it'll be white, black. So you're only looking at those transitions. Otherwise, and that's the difference between the 2 adjacent. So if you're doing the differential between each point, so like the difference between 0 and 1, the difference between 1 and 2, and the difference between 2 and 3, and so on, you'll get a value. So it'll be essentially 0, and then all of a sudden you'll have a spike where it made the transition. And then it'll go back to 0, and then you'll have another spike going the other direction. I don't know. I don't know. I can't see my own picture, so I don't know if you guys are seeing this. So when you look at, if you were just to graph the points out, you would just see a line that went across and went spiked up, and then went over the other side and spiked down, depending on how you define black and white, what's 1 and a 0 or whatever. So you see what I'm saying? So
yeah.
So you're only looking at those spikes on the differential of the sensor reads. So there's nothing super fancy about it. You got all that data. You just have to go through it.
Yeah, I think you guys should sit, you probably can see my screen, right? So I just wanted to show one of the limitations of my current logic as an example here. Does arc, right? So it thinks it's on top of a black line. That's because I'm seeing more white than black, right? My logic says, well, if I see more white than black, then the line is black, right? And so it's picking up the edges, but they're actually not really used right now for line centering. But you can see it's picking up this transition here. Here's a bit of a block, a chunk of black. That's the first chunk of black I see. That's got to be the line, right? And I'm putting my blue dot right there because that's the center, right? So it kind of shows the limitation. And one thing, and that's why I added these additional lines that I'm not yet all using, but what I've been wanting to do is for each line sensor, attach a piece of metadata that kind of represents the certainty I have in what I'm seeing, right? So what I mean by that is if I see much, much more black than white, then I'm more certain than that the line is white, right? Versus if it's more or less 50-50, right? I see a lot of black, I see a lot of white, maybe one is a little more than the other. Well, then I'm kind of half-half, and I can't really sort of rely on that, right? And I'm not explicitly tracking that right now, but I think I should. The other thing I'm thinking of doing is, since I have multiple sensors, and I'll probably add some more, again, if one of the sensors is picking up information that can't be trusted, too many edges, whatnot, right? Just use another sensor, right? Use the one that's in front or use the one that's behind. You can see my foremost line sensor. It's picking up exactly 2 edges, right? It's picking up mostly black, a little bit of white. So I can be dead sure that I'm on top of a white line there. There's just no doubt about it, right? And so I could just say, all right, I have 100% confidence in what that sensor is seeing. I usually use my arc here, but I don't have a lot of confidence in that arc. I'm seeing multiple edges. I'm in the transition phase here. So let me just throw that out and not use it and just go by what this sensor is telling me. So that's another idea I'm gonna pursue to see where that gets me.
Yeah, I think that's a good idea. I mean, I've done that too, where I have one sensor says confusing, other sensor is clean as a whistle. Well, then that means something. So that's definitely a good way to go. And I think for people who haven't messed with this much, I always get confused, even though I wrote the program. So the cool thing is with your controller on and you're frozen, you can drag your robot around right now and look at the sensors, how they register, right? Can you do that right now? Yeah,
I'm doing it right now.
Yeah, that's something that is real helpful if you're working on your logic, and you can play with the, he could turn the robot a little bit and see if it was critical, if it had to be, coming into that tile straight, which, if you can do that, that's great. It helps reduce problems. But if you can't, then you're going to have more time of confusion when you enter an inverted tile, at least conventionally speaking, but there is no real conventionalness, is there?
Can there be a expected maximum line width?
Yes, 1.5 inches, I think. Is that right, Doug?
There's 3 line widths. The basic one is 3/4, and so the large is double 3/4, so that's 1.5.
Oh, so it's fixed line width.
Then
Just a few fixed line.
the narrow line is 1/2 of 3/4, so that's 3/8.
Right.
But the trick with lines, though, is you do have to be careful. If the robot's rotated, a line can have a perceived width that differs. So yeah, as he gets that robot turned close to 90 degrees, those lines will look very wide. But there again, that's where you need a little logic to help guide you as to what's going on. And here, his multi-sensor array will tell you.
Exactly. That's where the arc helps a lot, right? Because the arc itself is also turning, right? So it's getting less confused. It's picking up a very narrow line here on the arc. It's very clear. Versus, like you said, on the straight line sensors will think I'm on a regular 3/4 of an inch line.
Well, if you have a diagonal set of sensors, so yeah, I'm glad to hear there's just a few fixed line width. Then that sounds interesting. We can reject these false lines, or maybe even decide the orientation.
Yeah, and the diagonal, just to mention for those that may not have played with it or seen the whatever documentation, you can rotate those line sensors arbitrarily. So if you want, a little 45-degree angle versus using the half circle or whatever, that you can do that. Oh, no.
One more question, guys. Sorry, Chris, can you share that again? I want to ask about this gate. I keep hearing a few times about the gate. I don't really understand what does that.
Yeah, let me hover on the gate, and you can see what that looks like. The gate is this thing down here. Okay, you can see the text here, gate. So, and what the robot's supposed to do, I was told last week, right, is you're supposed to ignore that left-facing part of the gate. You're supposed to go straight, and then you're supposed to take a right.
So the gate is always this.
The right turn, really, even though it was straight, it's the right branch.
Until we change it. That was the idea. The idea was that on alternate years, as everybody just conquers this because it's so easy, that the gate would change. In 1 year, you have to exit to the right. 1 year, you have to exit to the center. 1 year, you have to exit to the left or something like that.
How do you tell it's a gate? Because of the angle?
Well, that's your challenge.
I mean, what is the idea of a definition of a gate?
Yeah, like I say, the original course and that little curve, it was not there. So the two lines that are to the left turn and to the straight turn, they just would end. So you would have just gone off into the wilderness if you took the wrong turn. You follow me? I don't know when that curve creeped into the course, but
Everything is a distinct pattern, and I think it's pretty instructive if you take a robot that's frozen with a controller on with sensors, then as you move it around the course, you'll see you'll get a feel for the patterns. If you drive it toward the acute angle, you kind of see what's happening. Now, if you don't have if you just have one spot sensor out there, it's going to be hard to determine what's going on. But if you've got a line or an arc sensor or two, you can just literally see what's going on, and you'll see the patterns, and you'll see, okay, what does an acute angle mean? It means I see two lines for a little bit and they're getting closer together. Or what does a gate mean? The opposite sort of thing. At least that's one interpretation. There may be other ways to handle it, but definitely there's a number of great clues as to what's going on.
It really just depends on your concept for the sensors and your concept for how to resolve the sensors, because those can have a huge impact on how you approach the problem to begin with. So, yep.
Thanks.
Cool.
Hey, Jean, I think from like an hour and a half ago, did you want to go across something?
Yeah. Right. I want to share with the group what I've been working on last week. So I was I was trying to work with a motor, but started to play with this concept of a communication between Arduino and PC, right? So I'm still yet to receive data from Arduino. Where I'm working toward is basically I want to have several data sources from Arduino. It will mix everything into the serial line, and then on the PC side, I'll parse out the information, and some will go to a logging, some go to screen display, like the text information. And I'm close. I'm still working toward that goal. But anyway, I think I'm enjoying the process. But I'm first application would be to get my encoder behavior figured out. But yeah, anyway. So working toward it, and I just want to share with you guys so I'm not lonely in playing with it.
Not at all.
Yeah. Thanks.
Okay, cool. So at this point, I'm going to jump in. So I'm going to show, finally, I have something to share. And actually, what I'm going to say, if someone earlier, I think Murray, you mentioned Donald Knuth, premature optimization is the root of all evil. So maybe I'm taking that mindset a little too seriously, because there's absolutely no concern for optimization here. Not at all. Not in the least. Not at all. So I like that philosophy right there. And here's why. So you can see that, Ron, thank you again for humoring everything. And look at the progress that I've made. You can see here the outline of a mecanum-based wheel robot. Isn't that cool?
You spent too much time on the icon.
It was an hour and a half on Sunday morning, but maybe a little more in GIMP, but that actually is a photo of my real robot.
Hey, I just want to say before you continue, you have advanced farther than Chris because you actually plugged your name in and your robot name. I noticed he left my name and my dumb robot name
I
on
wasn't going to say
the.
anything about that, but yeah.
So
Well, you
Carl's
got something to say.
optimization was actually in the icon.
Say what?
Your optimization was in the icon.
My right. That was maybe premature optimization, but there's another thing here too. So watch what happens when I start this guy up. Now you have to watch closely, but it doesn't move like a normal robot does it?
Yeah.
Oh, so it's got sideways velocity like a Mecanum robot, doesn't it? Oh. Oh. All right, and then that's where the extent of my demo goes. My friends, that's what you get for a single line sensor. And this is in the public version of my repo. From here on forward, I'll only be doing private things. And I have to ask Ron, is there a way where I can make the opacity? I mean, I'm not asking you to change the color, I've done this already, but is there a way so that I can make the opacity hide the sensors so that no one can see my sensors when I do demos on screen?
Oh, well, you could color the, since you have the ability to color the sensor. Oh, I see. You would still be able to see it. Wait a minute. Let's think about that. Well, could you not, if you colored your sensors, they'd kind of go away, wouldn't they, if you colored them according to what they were seeing? Would that make them kind of disappear-ish?
Or if I made them be like translucent?
Well, yeah, I don't know if that's, yeah, you might be able to tell it not. Well, I'm sure you probably can tell it.
Why do
Okay,
you
so it's not designed in. I'll work around that somehow, but
I think it's there, Carl. I mean, it's the kind of thing that I know I wrote the dumb program, but I have to go look because my brain is the program, not I don't have anything on top of my shoulders.
it's no worries. I'm with you on that.
Carl, but showing sensor, it makes sense, right? People.
No, it makes sense for people.
people.
Also makes sense for the competition.
If you find a way, and that what shouldn't be too hard is, as a simple hack is if you just put a view, some sort of view panel on the top left, right, cover up the zoomed in view there where the sensor is visible. If you just cover that up with something else, then you've basically hidden it, right?
Well, what order is it drawn in, though, is the question, I suppose. But I'm sure you can find, I could probably locate it.
Well, it's another optimization problem because at some point it's really not worth it. But I was just asking. But anyhow, that's the sum total of the progress I made in the last 2 weeks. But I wanted to show you, I just want to say thank you, Ron, for humoring on the icon. And
Oh, sure. No, I think it added to the program. So that was a good add.
the sideways velocity is pretty cool. So I can't wait until next week when I can hide my magic sensors and then show something maybe better.
Carl,
Anyhow,
with the Mecanum wheel, how would you determine when you actually have to turn like clockwise, counterclockwise versus going left and right?
well, my lips are sealed, but the hint is that I'm not revealing my sensor pattern just yet.
Oh, so it's depending on the sensor pattern?
All I can say is that Chris, good luck with that, buddy.
Carl's car doesn't turn. That's why it goes off the rail at the end of the
Okay, I'm sorry.
Okay, Carl, I put your thing in there. If you look at LFSM, look for show sensors, you can.
Oh, thank you.
I did add in fact, in the latest edition, does yours have a quiet command?
I don't know. I'm up to version 1. Whatever, 5 something.
Okay, you might. Is it? Let's see. If you run it, hang on. Let me look. Is there a queue? Well, it doesn't matter. You'll see. I kind of. Let's see. Does yours? Wait a minute, did I? Oh, does yours have a quiet display? Let's see.
I don't know. Is there like a version ID or something?
Oh, okay. Yeah, okay, you don't have that feature, but never mind. There is still search for that show sensors. I do have a quiet display now that can blanket, but it was an attempt to speed the program up by blanking panels until I realized how to really speed it up. And a lot of that stuff goes out the window because I made it now like super fast and it won't matter. So anyway, but yeah, so you could go in there. The only thing is that since you are in a LFS panel or code, if I update the code, you'll have to go back in and repatch or come up with some clever way to fix your problem outside of those files. But I sort of say that I can pretty indiscriminately modify those LFS files in future releases, but I'll try like the devil not to mess too much with the other tabs. But I think I've done that a little bit for this warp speed thing. Does that a bit, but not much. It's very minimal interference.
Cool. Well, thank you. Show sensors. That will be my friend for next week. Let's see.
Okay.
All right. Gauntlets off, mittens on the ground. Who has a...
Well, I guess I have only a status report, no demo. I think last week I reported that my experience as a Java programmer did not translate very well into Python, and that I was using a lot of different thread loops and a lot of different threads, like maybe a dozen. Almost everything had a thread, and they ended up competing with each other, partly because the Raspberry Pi only has 4 cores, so it can only run 4 threads, but also just thread contention. And what I've ended up doing is I've rewritten almost all of the operating system to only use threads for, let's say, each PID controller has a thread. And I think I'm creating a thread for the clock. No, the clock itself doesn't have a thread, it just runs. And there's a thread for the game controller. But basically, I've almost got no threads. And what it looks like now, in an abstract sense, is actually a very early robot that basically the books that David Anderson's shown me from like the 80s and 90s and stuff I've read on papers and things where there's just that one microcontroller loop. That's kind of what I'm doing now. I've got basically, it's more complicated than that, of course, but the whole idea of having a whole bunch of interacting threads, you can't do that in Python. So, but I've almost got it running, and actually the performance is a lot better. So that what I've been calling my cruise behavior, which is that the maximum speed of the robot, the maximum forward speed of the robot is limited by its distance to a forward obstacle. So as it gets less than 1 meter away from something, and you gradually move towards the object, the speed will drop until you get to about 20 centimeters and it'll just stop. And then it doesn't matter what you do on the gamepad, you can sit there and say, go forward, and the robot will just say, I'm too close. And then if you back up, it can actually have a forward velocity again. So that's the behavior. And that's actually quite a lot better now because it's actually running that behavior in that overall loop and not trying to run it as its own. I'm going to have to, you guys have got me going, okay? Everybody needs a mustache. Anyway, that's it for me. I almost was ready to maybe do a demo, but it's not quite working. And because there's so much that I've had to change in the Python code to make this work and I haven't had that much time. I've been pretty busy, but yeah, that's it for me.
So between PID loops and threading and simulation speed, we have some regular topics coming up.
I didn't mean to bring up PID loops. Sorry.
Oh, okay. All right.
Don't say it again.
Let's see. Okay. Mr. Ray, how about you?
Yeah, I've been working on things mechanical. I've been trying to fit this wheel onto this motor, and basically everything comes from hardware store. So I had to make like an adapter between the motor shaft and the wheel shaft. Then this washer is going to get that's the adapter between the motor shaft and the wheel shaft for the hole in the wheel. This is just a washer that I'm going to weld on. This is a shaft collar that I'm going to weld on. And that's basically, I'm going to have holes drilled around this 6 holes. And so I was playing around with a little mini mill, creating, I don't know if you can see those or not, hole patterns, little black dots there. And I can copy the G-code file, and I'm going to try to run it on the Bridgeport mill. But I had to, just wanted a way to securely attach the this wheel to the shaft. It's the the shaft coupler, or not shaft coupler, shaft collar has 2 set screws, and there's 2 flats in the shaft that those 2 set screws will go into or try to catch. And then I've made basically a bearing hanger out of washers. I've bored them out. And these 2 will be welded together. I'll have a 1/2-inch threaded rod coming up here, so I can adjust it up and down. And I wanted to do that. This motor has a ball bearing on the output, but it has a bushing on the inside. So the ball bearing is here, the bushing is back here somewhere. And I didn't want to kind of cantilever the shaft out so far. And that's why I wanted the bearing hanger on the other side of the wheel, so it'll support it. The shaft's pretty thick. It's like 0.390 inches, which, a little bit less than 1/2 inch. But I just, I only have 4 of these motors. I didn't want to bend the shaft and, by putting too much weight on it, because it's going to have to support the weight of the mower, and pretty good sized battery that goes in the back of it. And, didn't want to overload it by sticking too much of a load, on this fairly long shaft. So that's about it. That's what I've been working on.
Welding.
Welding and using my lathe and using my milling machine.
It occurs to me that your robot's wheel weighs more than my whole robot.
Yeah, that's like a 7.5-inch diameter lawnmower wheel that, when Pam's dad died, he had like garages and sheds full of mechanical stuff. So it's like it took me a month to go through it all to figure out what I wanted and what I thought I could use in the future. And he did give me he had a 10-inch South Bend lathe that he gave me before he died. So I'm trying to piece things together. Like I had a rotary table, but I don't really have, I could put the rotary table on on the table or the bed of the milling machine, and that would work. But I was trying to attach it to the lathe, but the faceplates on the lathe have 3 holes, 120 degrees apart, and the XY table just has two areas where you bolt it, so that's not going to work with mounts that are 120 degrees apart. You be across from each other. So I was just trying to figure out, okay, how can I do this without spending all kinds of time and trying to get the mill to work and not destroying the mill because I haven't used it in a while. And very easy to screw things up.
Yeah.
We only have one of those too. So, anyway, so yeah, all things mechanical.
Cool. Very nice.
I always thought you could kind of, rather than going industrial, you could maybe go for like a flyweight mower, like maybe just turn a drone upside down or something like that.
Oh yeah, yeah. Yeah, the other thing that I was thinking is that, it's not very green, because they all have gas engines on them. I do have a leftover 230 watt solar panel. She bought 2 extra ones, and I thought about, making that the mower and just using, I have a budget of about 200 watts or so to, try to navigate the thing around and to mow, which isn't too bad, 200 watts.
So wouldn't it be easier to just put cement over everything and then not have to worry about mowing the grass?
Definitely would, but cement takes a lot of energy to make, so that's probably worse than a gas engine.
Okay. Just brainstorming here.
Yeah.
But I mean, Ray, I do like your idea of, because like, I don't think you can get, I mean, I lived in the States for, I think, 29 years, so I'm familiar with the brands, and we can get Milwaukee down here, but we get brands here that you don't get. And one of them, I think, is, have you guys, anyone heard of AEG?
AEG, no?
No, it's orange and gray, and I think it's
That's a
Australian.
German brand, is it not?
Maybe, but I thought it was Australian. In any case, my mower is an AEG mower, and it uses these big, giant, like quart of milk size batteries that are 58 volt batteries. And it uses 2 of them that you slide in, and then you have this plastic thing you turn. You pull it out and turn it. And it's just it just shorts out one battery to the motor and turns it from the other one.
Oh,
And it occurred to me that you could turn that into a switch, and then take off the push part of it, and put a steering wheel on the front and have a full electric mower with 2 big, I don't even know what the amp hours on those batteries are, but they're, I've got a 1/4 acre of land on which my house sits. So maybe 1/8 of that is mowable. And it takes with the grass along, it takes 3 of those batteries to mow my front and my back.
wow.
But 2 batteries in the back would do it. And I was thinking, maybe, but then you start going down this road of, these big giant wheels and these quite expensive, which in New Zealand would be outlandishly expensive, but like the controller you're looking at is quite heavy.
Yeah.
But I like the idea of an all electric where the mower's electric and the controller's electric and there's no petrol noise and
Right.
smell and all that.
Yeah.
'Cause my partner's actually okay mowing the lawn, where the petrol mower I had before was actually given to me by my next door neighbor, and it must have been like 30 years old. And it, giant clouds of smoke, and she hated that. So I mowed that lawn all the time. But with the electric mower, she's actually quite willing because it's not, it's nice little noise.
Yeah. That's the thing. I looked at one of the things that's, they call it van life. A lot of people are converting vans, and one of the things to do is to not have a gasoline generator. Actually use like pretty high capacity batteries. Like some people have 200 amp hour batteries. That and they've got like 3 or 4 of them. I looked into the cost. A battery that big is about $900. It's like, oh my god, and a gas generator is what, maybe about $800 now.
Yeah.
So it's just like yike. Then you have to have, you got to have a maximum power point charger. You've got to have a big inverter. It's just, it's expensive. It's nice, yeah. There's no, no exhaust, no fumes, no noise, but it's still pretty pricey. Yeah. And a lot of the solar companies are really pushing storage, and it's, I don't know. The batteries don't last that long. They're very expensive. It's I don't know.
But even in the last couple of years, even in the year and a half I've been building robots, these Makita batteries that I've been buying have doubled in capacity, and the price hasn't gone up. So figure a few years from now they're just continuing. There's so much pressure to improve the battery technology, and I think even Tesla's talked about some big breakthrough that they're gonna have soon. I can't remember. Anybody heard of that?
It's a million mile. It's a lithium iron chemistry. And it might have slightly more capacity, so slightly higher energy density, but for sure it has, I think, a 3 or 4 times a number of discharge cycle lifespan.
Oh,
Yeah.
wow.
So the idea is that
Lithium ion batteries don't tend to
Lithium
catch
ion.
on fire, right? I mean, they don't want to be charged or discharged, or they don't want to be charged below freezing, really, or very far below freezing.
lithium
I
ion.
think they're better tempered than some of the other lithium chemistries, and they're not too expensive. I've got a couple hundred amp hours worth in my van, and so far I'm liking it. Whatever built up, I guess 8 cells with a couple battery managers, and I don't really know how they're going to hold up, but so far pretty interesting. Great for supplying plenty of current. Well, let's see. I guess I have two 200 amp hour 4-cell batteries in parallel, and let's see. I can easily draw a couple hundred amps off those batteries. But
Are they the solid state ones, or are they more like the gel was the current lithium?
That's a good question. They're not sloshy. They can be operated in any orientation, as far as I know.
What do they cost, if you don't mind me asking?
Oh, let me think. I bought them off Amazon. Let me think. The guy is called Overkill, but he buys them from China. But I figured for just tinkering with small quantities, I like the idea of buying them from him. But let me think. Somewhere around, I'd say about $400 per 100 amp hours. So for 12 volts or whatever it is, 14, whatever it works out to, 13 something. Anyway, so I compared that. There's kind of a nice solution if you want a lithium ion battery and a good warranty, provided the company's still there in 10 years, which they probably will be. They're called Battleborn, and they make sort of a drop-in, looks like a 12-volt battery, 100 amp hour. But the cool thing about their battery is it does have about 20 or 30 cells in it, so if one or two fails, it just barely derates the battery. In my case, dealing with large cells that cost $100 and some odd a piece, if a cell goes, then then you're out that cell and maybe even compromise the battery. I know a little bit, but not that much. So.
Yeah. So that's in your Sprinter van?
Yeah, I use it to. I use the battery can run a window air conditioner. It's kind of crazy. My roof air is a hog, and it draws up to close to 2 kilowatts at times with the inverter overhead. But I have a little window unit that's 400 watts, and I can run that for about 4 hours off that battery, maybe a little longer. Oh, there you go. There's Battleborn. They have a good reputation.
600 amp hour bundle for only $7,400.
With all the other junk with it. But those run about $900 a piece for 100 amp hours. I came in a bit cheaper, maybe about $500, but I don't have a warranty, so I'm living on the edge.
My goodness. All
So
right.
that thing used to have a gas generator, and it got pulled out, or was it always battery?
Oh, my van?
Yeah.
Never had a generator. It's just a kind of a low-end camper van. And so it was kind of designed as a plug-in as far as the air conditioner goes. But you could stuff a generator on it, which I'd like to do a small generator at least. But anyway.
Okay. Very cool. So let's see. So a few people haven't heard from you. So Kevin, I think we've been very, very patiently distracting you in the corner. Anything to share this week?
So I've been busy at work, so no major progress. However,
Like something important on the whiteboard back there.
this club is all about urging other people to spend money, right?
Oh, look at you.
Just stood up. Just a Nano, 2 gigabyte version, 2 of them.
Up there.
Yes. So my intention was to put the ROS 2 on it and just run some experiment, but nowadays I'm kind of busy, so this may end up sitting in my thing for a while. But wanted to show off this arrived.
Very cool. That closet in the background is of no use unless you've got it packed to the gills and overflowing.
Absolutely.
with stuff that you meant to do 5 years ago, but that's
Yeah.
cool.
And
All right.
Carl is speaking from 10 years of experience of that. Because he's got stuff he meant to do 10 years ago still sitting in that same closet.
You know, decades add up, don't they, Harold?
Yeah, they do.
The only thing I can say is that if you're going to buy something, you better use it, because I've got one of these and I'm not using it.
Boom! Look at Murray
So one of
going
these
down the
times
mic.
we could have a whole session just on people holding up the things we bought that we haven't gotten around to yet.
Yeah.
Yeah.
I'm using it as a server right now. It's kind of sad. It's yeah.
Sometimes they work as drink coasters too. You can just set your ice water on top and
Look, well, no, on those you could set your ice water on top and end up making coffee out of it if you're doing the right stuff. So
there you
know.
go. Harold, what you got going on in the lab?
Well,
Aside from,
I will tell you. Let me go see if I can switch some outputs here on what I'm recording. So this is a couple things. So let me turn on my what I've got going on here. I got the Latte Panda, and I was trying to drive the motor controller with it, and it was doing a pretty good job. And then I had to power everything off because I got everything plugged in. I got my joysticks working. I got talking to the serial port. Man, everything's going. So I turn it all off to plug it all in and to connect up the stuff and make sure it runs off the battery so I could drive it around. I plug it in, go to fire it up to do some tests, and of course, the Arduino communication problem comes back like an ugly dog. Okay, and so I'm like, okay, so let's figure out what that is. And I bugged out of it, and I thought that maybe there's just something on the Latte Panda and the communication there that's just crap. So I got me a Metro, which is basically an Arduino. Did me a couple of tests on it. And I can show you what I got going on now. I energize my motors and come over here and launch up my... You guys can see the motors running around, right? Or the wheels turning around?
Yep. Lower left corner, yep.
Yep.
One of them. Yeah.
So let me move this a little bit. This is something called Terminal GUI, which is basically in curses. So if you're looking for a UI to do something, it was really easy to set up and it works. Kind of cool, and it's all pre-release .NET stuff. But if you look at my numbers, my X and Y, I've got all that stuff going, and my servo going with my 0 to 180 kind of thing and stopping in the middle around 92. But this thing should be stopped right now, and you see what's happening to my motors. I didn't have this when I was talking to the Arduino on the Latte Panda, so I suspect I was getting help by some other mechanism, because the damn thing just didn't work right. And so if I push forward, I'll get going forward pretty good, but you'll see one of them stalls out, and I'm thinking this is what Carl was referring to as jitter. And I don't have an oscilloscope, and I don't have a good. Well, I might have to do that. I got one of those knockoff, $15 Chinese logic probe things, and set up the Saley stuff and tap into this thing to see what the jitter looks like. But I did prove to myself that I am doing the right stuff. I am talking to it, and I don't need to be using the Arduino that's built into the Latte Panda. And I'm a bit frustrated right now, but because I'm not sure what exactly to do about that thing, and I'm not sure whether I've got some crappy connectors here or something else is going on. Maybe the baud rate settings when you plug in a USB port gets kind of funky because it's supposed to be a serial port thing, and the way Windows does stuff and the way USB port and the virtual port things work, that may not be a 57600 port that's coming out of there. It may be mostly 57600, that sort of thing, and that's what might be going on. I don't know. I don't have the tools right now to debug that at the moment, and I don't know that I have the patience to debug that at the moment, to be honest.
If the motor is turning, it's getting power from something.
Well, no. That's the power's fine there. What I'm talking about is communication, the communication from between the operating system Windows into the serial port on the Metro that's telling Fermata when to go. That's what I'm thinking is weird.
Is it a one-way command, or is there a loop in the
It's
feedback loop?
well, currently I'm just doing a one-way command on it. I'm just firing and forgetting.
And if it's over serial, right?
It's over serial.
Well, so
And in fact, check this out. See, it's going right there. I've stopped the program from running. I ain't sending crap.
Well, that's exactly what I'm getting from my robot all the time, is that weird ghosting behavior. Is that a PID loop running?
There's PIDs on the motors talking to the RC controller down here. Now, check this out. So these two, this is my left and right. This is my serial servo 1 and 2 signals that are going in. If I unplug it, everything goes pretty much quiet. This one's still crunking along because I think 0 is a bit weird on these things, right? So if I unplug this thing, then I'm cool. Right? Or pretty much cool. But if I plug it back in, you'll see.
all right.
So whatever this Arduino is pumping out is crazy.
So here's a question for you. What about, like, is there, so there's a traditional hardware software a fault isolation issue, right?
Yeah.
So since it's just serial, one-way serial, can you just take that serial and put it into a, show my age, VT52 emulator or some kind of terminal?
And just watch it as it comes out?
Yes. Are you getting the same characters over and over again?
Well, let me see if I can show you about that. If I go monitor that port, like I've got my Arduino IDE up here, and I'm talking to COM6, and I go to monitor this thing, this is what's coming back, because it does two-way communications on it, even though I'm firing it that way. And I set this thing to
the right baud rate.
The right baud rate. This is what comes back. I got some binary stuff going on there.
So, but what's coming back isn't what's moving the motors, right?
No.
What's moving the motors is surely got to do with what the thing's receiving from your computer. So
yeah.
So I'm just wondering if you can put just a terminal receiver in place of the thing driving the motors. Then I mean, is your so?
I got you. I got you.
So
I got you. So like on this side of, if what's driving the motors here is it going to be a servo input? It's going to be a pulse width. That's what's going to be talking to the motor controller. It's not telling the motor controller to move it this far. I've got the motor controller in RC mode, so it thinks it's a servo, like a radio control servo input is what I'm sending out is servo output.
Well, so that's another way, right? Because if you wanted to break the loop there, you can tell from the position of the servo if the servo's erratic. Then the noise is creeping in there, right? Yeah.
So I've got some more ideas of tests. I just don't know how interesting this is going to be on Twitch to be doing. So I may build a project. So this is something called a Fermata test thing that came from the people who built Fermata. It's a C++ program. It's been around for ever and ever and ever and ever and ever. And I went and downloaded it, and it seems to be working kind of well. But I'll show you what it does. It goes out and talks to Fermata and interrogates it. And then 5 and 6, like for 6, this needs to be a servo output, and so does 5. And if I do that's full backwards, and that's full forwards, and that seems pretty stable, right? Well, see, that's weird because it's now turning left. I didn't tell it to turn left. Now it's just.
So
if I can get
it seems like you've got to break down it.
Yep, I've got to go take it all apart.
The commands you're expecting to from your computer, yes or no, and if you are, then is it interpreting the command it's receiving correctly?
Yeah. Because it's now pretty slow. So one of these goes forward and backwards, and the other one goes left and right. Even if I just leave all the stuff static, like go all the way up, right? So I should be going as fast as I can forward and turning left or something. Turning left. I would expect this motor here to be going just a little bit, maybe. Maybe I don't turn left as hard. So there's something weird going on, some interaction going on there, right?
Yeah.
That seems a bit weird to me, like there's crosstalk or something going on there. I don't know what that means. So part of the other thing I was going to do was I got this Teensy laying around, and I was going to put some headers onto that, figure out how to program that thing. And then I was going to do the same kind of test with it to see maybe I just don't have enough juice here. There's something weird with that board as well. I don't really think there's anything weird with the board. I just don't have a good way to see the signal. Put it on there. So I'm a bit flustered. So I think what my next twitch is going to be, which is tomorrow night, I've got this kit here from Adafruit. It's been sitting around for about 2 months.
Whoa.
I figured I would solder some things up, put some eyeballs on it, use a Raspberry Pi over here, make some eyeballs move left and right, just to get away from this for a little bit and get back, build up some more energy to deal with this, so to speak. So that's kind of where I'm at on the thing. Here, let me turn off these motors. Thank you. So I came real close. In fact, I fully expected to show you guys video of me running this around the house and scaring the dogs. But I don't know if I'd scare the dogs. They definitely would not know what to think about this.
You can scare the dog with the eyeballs, though.
Well, I can do that too. Well, the thing with the eyeballs is I can eventually mount them in this thing here. And here, let me give a better screen. And I'll go back recording ourselves. One of these things here, I've got some stuff printed up where I can mount the eyeballs in the back side of this thing, and that's going to look pretty goofy, I think.
Nice.
Kind of freaky on the feel, and that's kind of where I was going to go with it. But I've been on this pretty steadily, and I'm like, I think I need a little bit of a break on this, because literally I get on the Twitch, and a couple hours later I get off the Twitch, and I'm just almost solely concentrating on this, or I got a presentation to do Friday at noon. That I've been making sure that still works to do the presentation. So I'm like, okay, I think I need to switch up just a little bit on it, and have a good old time with that. So that's kind of where I'm at in the thing. And besides, I spent $25 on a Teensy. Thank you, Murray. And I got to see the damn thing work. At least power up and blink an LED. I mean, come on.
Oh yeah.
Yeah.
I'm sure you'll enjoy it.
I have no doubt that I will. And now we've got the catastrophe that just showed up.
The catastrophe.
Oh, dude, the last Twitch stream came on here. He was laying up here, and they said, hey, could you pet the cat, please? I'm saying, I'll pet the cat. I got 3 more viewers off the thing and 2 more likes and a couple of followers, and I don't even know. Maybe I should have the cat around all the time. I don't know.
Probably
It's
should.
on the internet.
Yeah.
There's a cat person in the
Hey, come here.
I think the internet was made for cat videos.
That nose of yours.
Yeah.
This
So my
cat.
suggestion regarding your problem that you're having with your motors and stuff is you've got several different things going on at once, and you don't know which one is the problem.
Yep, and I'm just trying to figure out which one. Yep.
Disconnect your 2 computers apart, and you just use the motor controller with the Uno that you have there, or Mega, whatever it is.
Yeah.
Just get it to actually respond to a script on that thing. Can it control the motors correctly? And then after that's working, you can add in the command.
I've got those. In fact, I can do those tests now if you want to see. I got one of them. In fact, let me put this back now, I guess. Come on.
Because I'm hoping I don't have the same problem you have when I put my 2 computers together, one controlling the other.
Recent. See this? I see you.
Yeah, they have servo examples for.
Yeah, I think I've got one that does what I want to do, though. Like this one. See, this goes full forward, full back, that kind of thing, right? And I've got this. This is one of the test thing that you folks have seen before, but I haven't not run in a while. And so I've got it so it prints out. It's not doing the. It's just a serial thing. Lets me know if I'm going which way I'm supposed to be going, and this all min and max stuff or some numbers I worked out for the pulse width on it, right? So I'll fire it up and push it in. I'll take a second.
Well, I have to say that Doug's idea is obviously the first thing you do is simplify things, because one of the things I found with my PID controller was that people may remember that even after I'd stopped my robot, I'd get this kind of back and forth movement with the wheel. And that turned out to be entirely inside the PID controller. That even though I'd said turn the velocity to 0, it was actually just the PID controller. There's no hysteresis, basically. It was just going back and forth, trying to solve a problem on its own. And so if you're using a PID controller, Harold, I'd say maybe not use it for a while, because the kind of behavior I saw in your wheels was kind of similar, not the same, but similar to what I was seeing. Because you got a complicated feedback loop with your encoders and your PID controller and your motors and your synchronization. You know,
this is see, Doug may have hit on something. Let me show you the serial monitor on this thing now.
Bloody PID controllers.
Bloody hell.
See, that's supposed to be stopped. So you may have hit on something. Okay.
Yeah, if you say to the motor or to the PID controller, set the velocity to 0, or you should be stopped, and you still have motors moving, it's probably your PID controller.
Yep, there's something weird with that, isn't there? May need to go in there and reset the thing and see what's going on. See, it does act a bit weird.
And as you said, it also could be some kind of electrical crosstalk as well.
There certainly could be. So yeah, I that right there, I ran this test before on the Latte Panda directly on this using the Arduino on the Latte Panda, and that was 100% nailed, exactly doing what it's supposed to do. So I may need to just go back to step 1 again and make sure that thing is doing what it's supposed to do, and load up that thing again. See, because what it's supposed to do is something like, let's stop this. Thank you. I'm going to power you off. And then what it's supposed to do is do this. You guys can see this, right?
Yeah.
So I'm firing up the basic micro. Make sure you guys can see. This is a little bit of controller thing that's supposed to be on here. So I know what I'm doing wrong here. I need to unplug this. Oh, not that.
Now, there's also these purple dots on your screen. It's kind of weird.
Purple dots?
At least I'm getting them.
Really?
Yeah.
All right. There's this.
Okay. If you're not seeing it, we'll just make you think you're going crazy.
I think you're going crazy.
Okay.
Okay. So I need to get this out of here from not there. This out of here. This goes into that.
It's not a conspiracy of what we're doing in the chat to drive you nuts, but
I think it is, but that's okay.
We'll see if there's something there in the recording.
Okay. So now I can connect up to this thing, which allows me to control this directly. And so in the general settings, it does some stuff when I do in the PWM. And I'll just sync up the motor just so it's nice and easy. See, that's weird because that should be going forward and backs.
Well, it's moving a little bit.
Yeah, but it should be squat. So general settings, I've got it in RC mode. What if I take it out of RC mode and put it into simple serial? And then I go into here. Yeah, it doesn't work with RC mode the way I've got it in there. So I can do that, right? Uh-oh.
Well, it makes me think that the RC mode is getting an RC
It's
signal from where you're not expecting.
Getting me what I'm thinking, right? So stop all of those things. Oh, well, wife just brought me in some
You know, it would
blackberry
be
cobbler.
just a crime if it was like a ground loop problem on the RC signal between the controller and the.
You know, that's one of the things I don't have. I needed to get a ground going from. Hold on. You guys may have just hit on something here.
Just get a nice solid ground between the
Project.
two boards.
Yep, I've got a ground and there.
Where can I put this for your
Right there.
doggy's head?
Oh, doggy's head whipped cream? That's awesome. Okay, so if we do that, I plug you back in here. And then I get this thing back. Take you out. Where's my device again? General mode. Make sure I'm in RC mode so I don't do anything way stupid. I haven't written that out, so that ought to be good. In fact, why don't I turn that off and turn that back on? Because I haven't written anything to the EEPROM. If I do that, and I need to then open up a recent sketch, standard formata, load it. Let it run. Send it in. Okay. Now it's sitting there and it's quiet. You know? And I
Well, it's good to get rid of the noise, but when it gets rid of the signal at the same time, that could be an issue.
Well, yeah. Oh, it's quiet because I had the power turned off the motors.
Makes a difference.
It does.
That's a good way to get rid of
It
the noise.
does, because what's happening is I've got a startup problem that this, I got to work that out. Because what happens is there's a low voltage sense on there, and when the motor controller goes into an error state, you have to do the low voltage somewhere for or whatever error state in. You have to reset the thing. Well, holy crap!
The missing ground, huh?
The missing
Is that what you
ground.
expected now?
That's exactly what I'm expecting. Because
Harold,
if you can see the thing, you guys fixed my problem. This is awesome. Okay, I feel better
what's the
now.
price of admission?
See, if you can watch my thumb and some of the
Yeah.
fingers. Push forward, pull backwards, left, right, a combination of stuff. I've been playing around with the dead zone in here, and I need to go work on that some more. But that's exactly the way it's supposed to be. So I just had a grounding problem.
Ground loop.
No Bushmills for you.
I know, I'm an idiot, but that's okay. Everybody knew that.
Oh, no, that's awesome. I mean, that's just the obvious. It's obvious when you see it, but not until you see it.
Yeah, that makes me feel way better. Now I need to figure out where I want to mount this Arduino thing on here. Print a couple things up to mount it. That'll work. Yeah, I can make that happen. That's cool.
Get it going.
I guess I won't be working those googly eyes tomorrow night then.
You can still do.
I might do them just to switch up a little bit.
Yeah.
Hey, you got to put the robot down on the floor and drive it around at least a little bit.
Yeah, I know. I need to get some batteries I need to get the batteries put in there and do that, and I can do that. In fact, I've been charging batteries last couple of days because I've been doing some woodworking. I found out this last weekend that I've got software developer hands now, and what I mean by that, I had a bunch of 1x2s and 1x3s and 1x6s I was bolting together for frames for various things. You know, they're just the standard old whitewood, nothing, no big deal. And I go to pick one up and kind of slide down a little bit, and I got half a dozen splinters in my hand, and I had to go pick them all out because they hurt like hell. And I'm like, you know, back in a much younger me, those things would never even bothered me and gone. So now I've just, my hands are just too soft and dainty, I suppose.
Delicate.
Yeah, I'm just delicate now. I'm a delicate flower. Yeah, but thanks, guys. I'm much happier now.
Cool.
And the other thing is, I know the UI that I've got going on here is not that big a deal, but setting up a variable and talking to it and drawing those boxes around things and being able to tab through them, it's got a little menu thing and all that kind of stuff in it. It knows how to respond to mouse clicks and all that stuff. It's dead easy, dead simple to set up. And I don't know how many of you guys care about UIs for your thing. I know that Doug had sent me some things about some fancy graphic stuff, which I would really like to do some fancy graphic stuff. But in this case, all I really care about is visualizing the numbers coming off my stick versus what I'm trying to send into the robot. And this is more than adequate to do that. The only real problem about this is that the driver I'm using that gets me those numbers only knows about this left joystick. The right joystick, it thinks it's a D-hat or something, and it's acting really weird and doesn't really do what it's supposed to do. So unless I get in and do some open source stuff, that's what I've got to work on with now. And I may actually do some open source stuff on that because sometimes it's fun and learn something, and it helps other people as well go further. But anyway, that's about all I got. And thank you very much for your help. It's awesome.
Very cool. Yeah, that's great.
Worth the
And
price
thank
of
you for
admission.
reporting.
Yeah, worth the price of admission in that one. So I'm gonna dump off here and put us back to our regularly scheduled program.
Okay.
So we're recording the browser, and away we go. All right, we're now back to recording the browser. So
Thank you very much, Cheryl. All right, so let's see. I think there's maybe two more who we haven't touched on. Mr. Ackley, how about you? Are you having a good week, I hope? Ignoring the news, I hope?
Well, not much going on here, unfortunately.
All righty. By any chance, and I shouldn't put you on the spot here, but offline, I want to ask maybe about the mid-November dynamometer thing. You know,
No, unfortunately, as most things go, it's taking me at least twice as long as I thought it should. So it's more like a December.
all righty, no worries. We'll figure something out then. Okay, cool. Oh, that's all right. And then I think that's Mr. Doug. So saving the best for last. How have you been this week? Any luck with things?
Oh, wait a minute. Well, I haven't had a chance to do too much with robots, but because of David's email, I had to make me a hat. So I've been sewing here
Very nice.
the last little bit. When you're bald and it gets cold, you need something. So, and you never know when a soccer ball is going to come out of the left field. So anyway, I thought I would. That's about the only creative thing I've been doing this weekend. So I also been thinking about the simulation, but Ron keeps changing that damn program all the time, and
Well, you don't have to update it. You can just use whatever you got. Just, and I'm not changing much.
Okay, well, I'm hoping I've got some stuff that I had some stuff working on 3.1, and I tried to go to, I guess it was 3.3 or something, and lost the Fox, and then so now I'm going to go to 5.1, and we'll see how that goes. But Yeah, I want Ron. I'm not complaining. I really,
No, that's all right.
I really appreciate your work and effort on that.
Sure.
So cool. I mean, you know, I kind of keep myself from my own problems with processing. Yeah, because I want to set it up as a processing environment. You know, where it's part of the sketchbook.
So what do you mean, the library or what?
No. It works real well. But every time it gets changed, I have to recreate it. Otherwise, the way process.
Be careful if you load the example sketch. I think I mentioned this in the documentation. Be careful to save it out away from the examples folder, because that gets overwritten when the new library is downloaded.
Yeah, well, no, that's what I was saying. I was trying to keep it as a processing sketchbook.
Right.
Okay, but when you add, but the sketchbook to work has to have all of those files in it. So every time a new file is introduced, then I have to recreate it.
I'm a little sketchy there, but maybe we could talk about this outside of this meeting.
Yeah, but that's it's fine. Like I say, that's my issue, not yours. Don't worry about it.
Anyway, there's so few people, I probably could help clue you in. You know, if there was some mystery or something.
No, I'm just like I say. So, like, probably the easiest way to do it is put your newest distribution in, okay? And then, so now you're in a directory, whatever directory you call it, LFS, for example. And processing will create a library directory and a few other things. And the distribution is pretty much put in the library directory. Well, now when you make your own program, then what you're supposed to do is create another directory with the name of the program, of whatever you call it. So let's say call it Doug's Robot. Well, I have to have an entry in the sketchbook directory called Doug's Robot, and then inside of that, I have to have all the files that makes it work.
Well, one thing is, if you have a sketch and you have it loaded in processing, let's see if I'm talking the same language here. One really helpful thing is when you do a save as to a new name, it takes the entire sketch and clones it and builds a new directory and puts all the files in it and renames the main tab to that name. So that's a great way of go ahead.
Yeah. No, like I say, I think I know how to do it, but every time a new file comes in, it's not a problem of creating. You can take the simple bot program with all of its files,
right?
Okay, and you create a new entry in the sketchbook, which would be, let's say, Doug's Robot. Okay,
right.
And then all you have to do is go to simplebot.pde and change that one file name to Doug's Robot. All right, but now I have to import all of my code into those files, and they're all over the place because what's been in the different files has changed over time.
Man, I'm a little bit having trouble, but that's maybe me.
Well, don't worry about it.
Okay.
I can catch up. I mean, it just needs just. Are we finished?
Well, if you want it to run 100 times faster, no. But you just stick with what you got. But in a couple days, I'll have a rendition that'll run the simulation when you want to. It'll run it 100 times faster. But it doesn't, there maybe is a line or two in your code that's different.
Okay. All right. Well,
But it's up to you. You don't have to download the updates. But anyway.
I'm gonna be running. Everybody else is running. So no, I'm not being critical at all.
No. I understand that creating difficulty for people it's not what I'm, but I can understand how it happens. Gee.
Yeah. Yeah. So anyway, I'm just so right now I'm just trying to work out the newest version, and because you see, I add some stuff to mine too. You know, I add data logging and a few other things like that too. So you know that has to get pulled in, and
Well, maybe just don't update the edition. I don't know.
No, that's not what we do.
no, I just I'll figure it out.
Okay.
Yeah, but keep working. You know, if you've feel like you're making additional progress on making it better, I mean, I don't want to stifle you in any way.
Well, I'm pretty much done, but I was bothered by the slow frame rates, and I wanted to fix that.
Frame rates looked like it was doing pretty good to me.
Right.
Yeah, I think it's fine. All right. So, like I said, haven't been able to do much progress on it. Hopefully, maybe next week I'll be able to show some controller.
Great. Well,
Chris was good today.
Yeah, Chris has done good.
Yeah.
Yeah, we got to catch up with him. He needs some competition.
That's true.
Yeah, it looked like he was moving very fast. One thing I noticed, by fast, I mean, I looked at his, I think I saw a velocity on it, and it looked like he was gunning it and running it way up in the velocity. I haven't been that bold. I mean, I do have the idea that if I'm on a straightaway, to go fast, but he may be pulling some real cool.
Geez.
Yeah, well,
He's trying to be optimal.
Yeah, I guess my thought of it is if I can just get around the track, that's golden, because that means that I've got a simulation that works.
Right.
Start trying to put it into the real. And I actually like the idea that Kareem had, because that's more like probably how the robot, so you've got a PID loop on each side.
Right.
You're probably abstracting that up into, like you say, a turn angle and a speed, but on you could bring over more of the core the base robot into the simulation with that idea.
Well, look for it. I guess the next edition will have another demo program, and that is one that does have the left-right
Okay,
wheel.
I did have a question about something he said. Okay. With control over the speed of both motors, which we now have added basically, what's the start say? Really you could get a very quick turn angle by stopping one of the motors and letting it whip around, right?
Well, yeah, but really you're still confined by the limitations of the LFS. So, but what I did for him is I just implemented a transform from left-right wheel velocity, and also you need the addition of wheel separation.
Yeah,
that's what then gives you the ability to generate a forward speed and a rotation rate, or a turn rate.
Yeah, now here's the other thing I had. Like in Will's Trike model, since he's essentially translating, otherwise the steering is moved back behind, some distance from.
Right. It's a backwards tricycle is what he's doing.
Yeah, so when he turns, he's using, are you measuring the turn rate of his steering wheel?
No, he wrote a transform that takes his wheel angle and the drive speed of that wheel, and that is then transformed into a speed and a turn rate, and it's identical to what you can do with a two-wheel differential drive robot.
Okay.
So
he's not using the moment of his steering angle to accelerate.
No. So he's confined by what the limitations of the simulation are. He doesn't push it. Anyway, he only drives like 4 inches a second or something like that. His robot looks fast because I bumped his delta up to a 50th of a second, so it looks like it's running faster.
You know, I personally will be trying to go slow for,
Yeah, it's a pretty good idea.
and then see how that goes. Because like I say, if I can get through this course in the simulation, and I have achieved my goal,
Yeah,
because then I can take it or try to take it to the screen. And then I think, you know how Will has built, in his case, I believe the box is directly between the axes of the wheels. But,
yeah,
and on mine, it would have to be forward of that. And I'm trying to figure out how to build some sort of box and have my camera point pretty much straight down, so like I can control the environment.
Sure. Sure. Well, didn't we sort of talk about that as far as next time we actually run a physical contest somewhere, is the ability to say, hey, look, you can control your lighting environment, you know, have the lights turned off, and you can supply artificial light, and just go with that. Just because, you know, obviously there's ways to deal with ambient light, but, you know, who's to say? You go to the Perot Museum and there's sun blasting in through the...
I actually would like to have a solution that controls the environment of the light, so that I could be in the
Sure.
You know, it's because it's totally independent of that.
Sure.
You know, just like, you know, the little simple line followers that most people build, you know, you get it down close to the ground and you have like a little brush or something around it so that you don't get any ambient light coming into the sensors. The same idea. But that's, anyway, this has been cool. This is really, I've seen some interesting ideas from Chris's work and also from Will's work and Ron's work too, you know, even though we don't know the ins and outs of it yet. But I'm real interested to see how it all goes. And I'm real interested in Carl. Hey, Carl?
Yes, sir.
I don't think you have to run, you know, you in your robot, you shouldn't define a front and a back end, I don't think. You should
I'm going to implement it. I have two different ways to run the course in the mode that I have in mind.
Yeah.
I have two different sensor patterns.
Yeah.
One will be implementable with arrays you can buy off of Pololu, and the other one will be implementable with a camera. Yeah. And I don't know which. I'm probably going to start with the Pololu ones just because it's just that the Pololu ones they require too much soldering. So if I use the Pololu ones for this contest, it'll just be because it's easier in a way.
Yeah, are you using the RC ones or the analog ones? Do you know?
Analog, because I don't want them to have, I'm using the medium dense, okay, so like if you look at this chassis that I've modeled, this guy right here.
Can't see anything, bro.
Yeah, you're
what?
You're a little brown circle that pulses when you talk. I thought that was another one of your little get-ups.
Oh no, that's crazy.
Oh, that's the coolest one yet. It's a brown circle with a C in it. Wow, I like that better than Abraham Lincoln.
I've been flipping through all these cool things.
Anyhow, so reduced himself to the elemental.
I'm the C. Okay, so anyhow, you've seen my robot before. Anyhow, so basically they have a 13 sensor by 4-inch wide line sensor.
Yeah.
And they have it where it's low power and it's analog output. Because the digital ones have a fixed threshold, and I don't want to rely on their threshold. So if I use them, it'd be the 13 low density, so 4-inch wide, 13 sensors, and it require 4 of them. But then that's like 4 times 13 A to D channel. That's just too much to mess with. So I think in the physical world, I'd want to go with a. Oh, that's why this is muted there. Okay.
And the camera's
in the physical world, I'd want to go with the camera. But for the simulator, I might just do the Pololu.
Yeah, right.
And the 4 inches,
Actually, yeah.
now I can do it because I remember to turn it on. The 4 inches, oh, look at that, it got my face even. Wow. That's pretty good, isn't it? That's some pretty good, wow.
Just don't hold up a soccer ball.
For blending, I mean, it's just pretty crazy that it's able to mix the things, the realities. Okay, anyhow, so it's 4 inches. 4 inches fits well between the motors in both dimensions. So, and it's wide. 4 inches is almost wide enough to get across the widest line and still have a little bit of play.
Yeah, if you use their standard 8 sensor one that they used to make a long time ago, their classical sensor.
Yeah, they're old ones.
It's not wide enough. It's not long enough. And the new ones, they have some that are like 32 sensors.
Oh yeah, they have a 4 inch and they have a 5 inch.
Yeah.
And it's kind of buggy in here. What can I say? Yeah, so.
Carl, you're a 9-year-old.
In your mouth? Will the spider go in your mouth?
Oh man, I'm gonna have that's just wrong. Wrong. I'm saying, talk to them.
I'm so well prepared.
How many people do we have tonight? Counting. All right. Right. Okay, guys. So, hey, Ron, I wanted to ask. On a serious note. No, really, on a serious note. So,
Yeah, right. You passed that a long time ago.
okay, on a serious note, Ron, this is as serious as it gets. Can I merge my hover sim thing in with your master branch? So I have another example. It has the demo that I have with the, with the hover sim. So I'm going to make a pull request to your repo. If you're going to do another release anyhow,
It might confuse me. I am pretty dumb, but I suppose if just somehow if you want to stick that, whatever, we can tack it in because I'm dumb. Maybe I can figure out how to do your pull request.
You did the first one already. We can take care of it. I'll put it out to you, and you can
scoot down a little so I can see the rest of the cat. That's pretty cool.
If you have I'll just put it out there. If you have any questions, you can give me a call.
All right. Hey, the cat doesn't have rear legs, or sometimes it does. Oh, that's too creepy.
That one's not as, yeah. It's pretty wild though what they've been able. I mean, I don't know which one that is, but some of them they attach really well. Like
that looks a bit like you actually, just like without shaving.
The election. Oh, okay, yeah, like me without shaving. That's great. So, and that looks like me just on a bad morning. But
I don't know.
Anyhow. Okay, so I'm sorry, guys. Thank you for humoring me on this ridiculous night. So I've just wasted all kinds of distracting time, but thank you for humoring me.
Sure.
So are we done here? Are we done?
Yeah.
Are we involved?
Done.
Are we ready to count some chads?
I think
Let's count some hanging chads this week. Okay, yeah, bring on the mustaches. All about the mustache. That's no problem.
Yeah, I don't care who wins. I just hope it's not close because I don't want to endure the agony of the close election business. How's that? I guess technically we're not supposed to talk politics at DPRG, so that's the most I'll say.
Oh yeah, that'll never happen. Okay.
Well, I hope you guys next week then.
All right. Well, hopefully we're still here next week and we're not some.
Exactly.
I don't know.
All right.
Thing. Take care, guys. Good night.
Good night. Thanks.
Bye.
Uh-oh. I'm trying to go away here.